So next is our BCNF, Boyce Codd Normal Form. Before that, we have already covered first normal form, second normal form, third normal form. In first normal form, we have removed all the values that are repeating groups, and we have created the table that contains only atomic values. When the table, all the fields contain atomic value, then we can say that this table is in first normal form. Then in second normal form, we remove partial dependency, and in third normal form, we remove transitive dependency. So if we remove partial and transitive, then our table is in third normal form. Okay, so the next normal form that we are going to cover is Boyce Codd Normal Form. Boyce and Codd, these are the two different scientists. One is Boyce and another is Codd. So they are two scientists. They propose this normal form. They observe this normal form in some special cases, and that's why its another name is also 3.5, because it is not a fourth normal form. It is an extension of third normal form. In fact, it is a special case which appears only in some of the cases, and in those cases we have to perform some extra normalization. That normalization is called BCNF, Boyce Codd Normal Form, and another name is 3.5 normal form, that is 3.5 normal form. So it is more stronger than third normal form, and it require when the table contains multiple candidate keys. So this is a condition. So if these three conditions met, only then we need to do BCNF. Only then we need to break down our table further to create the table in three BCNF, Boyce Codd Normal Form. The first condition is that table must contain multiple candidates, and those are composite in nature. The second condition is that multiple candidates should be composite in nature. What is composite in nature means? There should be at least two or more attribute combined. They will make a primary key. So your primary key or candidate keys will be composite in nature and are overlapping. Third condition is that they should be overlapping also. That is, there should be a common attribute that will be shared among all the candidate keys. So if these three conditions satisfy, if in your table you have these three kind of conditions, that your table contains multiple candidate keys and all the candidate keys are composite in nature, and there is a sharing of common attribute, that means there is a overlapping of some attribute in the candidate keys, then there is a case, then there is a need to further decompose that table in order to get that table into BCNF form. So if third normal form, a table in third normal form that does not have multiple overlapping candidate keys, then it is already in BCNF. Then we can say safely that this table is in the table which is in third normal form. It is also in BCNF form if it does not contain any multiple overlapping candidate keys. So it is a very special case that occurs rarely, but if it occurs, then you have to break down the tables into further subparts. So let's see one example also. Consider a table that contains data about the student, courses and instructor. So assuming that the following conditions are true for this particular table, that each instructor takes only one course. So if one instructor is taking only one course, and each course can have one or more instructor, each course can have, for example, if someone is teaching math, then we can have two or three teachers that are teaching math. So this means each course can have one or more instructor. Each instructor takes only one course. That means if T1 is teaching math, then he is only teaching math and he is not going to teach any other subject. So each instructor takes only one course. Each course can have one or more instructor. Each student only has one instructor per course. Each student only has. So if I have student 1, and if he is reading math, and there will be only one instructor that is teaching math to student 1. It is not like that T1 is also teaching math to student 1 and T2 is also teaching math to the student 1. So this case will not be there. So each student only has one instructor per course, and each student can take one or more course. This is also another possibility, that each student can have more than one courses. For example, student one can be studying math as well as English as well as science. So one student may have multiple courses to his name. So these are the restrictions. These are the restrictions on the database, on the table, that is going to hold these three values: student, course, and instructor. So let us see the table. Some dummy entries for this particular table will be like this. So I have a table student, table that contains three attributes. One is student, one is course, another one is instructor. So for example, student Karan is in the course biology, and instructor is Sapna. Second student is Gurjeet. He is in the course math, and the instructor is Harpreet. Third student Guneet, course is science, and instructor is suppose Rajdeep. Similarly, Sikandar is also studying biology, because biology, that's one of the teacher of biology is Sapna, so I can write Sapna here. Then Sumandeep is studying science, and Rajdeep is the instructor who is teaching the science. Guneet is also teaching math, also studying math, and Harpreet is the teacher of the math. Samreen is also studying science, and Prabjot is the teacher of science. So you can see, for science we have two instructor, one is Rajdeep and one is Prabjot. And for math we have Harpreet as instructor, and for biology we have Sapna as a instructor. So this is one of the dummy table that is representing this particular scenario. Now let's see, let's find out what will be the key of this particular table. Can you find out? So let's think about this. Who is teaching science to Guneet? Who is teaching science to Guneet? That means given a student name. So here it is given a student name and course name. Can I find the instructor name?
Yes, sir.
Given the student name
Yes,
and
sir.
course name, I can find the name of the instructor. So that means name of the instructor is dependent upon student name as well as course name. So
Course name.
there is another way to look on the data. Which course is taught by Prabjot to Samreen? Or we can find out, given a student name and instructor name, can we find out the course name?
Yes, sir. Yes, sir.
So given the student name, given the student name and course name, I think it is instructor name. Given the student name and instructor name, I can find out the course name.
Course name.
Given the student name, given the instructor name, I can find out the course name. So this means this is also primary key. This is also candidate key, that given instructor is dependent upon student and course is dependent upon student and instructor. Course is dependent upon student and constructor. So this means in this particular scenario, we have two candidate keys. One is student and instructor. Another one is student and course. So these are the two candidate keys in this particular scenario. And second, so for our first condition met here. First condition, that table must have multiple candidate keys. Second condition is that those candidate keys should be composite in nature, and our second condition is also satisfied. So candidate keys, I have two candidate keys and both are composite in nature. Composite means they both consist of two or more attributes. So at least two attributes should be there. So it is composite in nature. And the third condition is that the overlapping, some of the attributes should be overlapping. And you can see I have a student attribute which is common to both the keys. So it is again, the third case is also satisfied here. So it is a case where we need to perform Bcnf. Got my point? So you have to check if there is a multiple candidate keys. You have to check if candidate keys are composite in nature. If, and third one is they should be overlapping also. There should be some overlapping of the attribute in the candidate keys also. Then we can say there is a requirement for the 3.5 normal form, or you can say Boyce Codd normal form. Only then this table will be decomposed further in order to achieve the Bcnf. Thus we have multiple candidate key, we have composite in nature, and they are overlapping. And what is the problem here? Problem here is again the redundancy. You can see that Sapna teaches biology. Sapna teaches biology. That fact is repeated again and again. For example, here you can see this entry, this information is here, and the same information is repeated here also. Okay, so got my point. So again, similarly, Rajdeep is teaching science, and same information is repeated here also. Harpreet is teaching math, same information is repeated here also. So you can see what is the problem of this case. What is the problem if these three conditions are met? What is the problem? So if we have multiple candidate key, if they are composite in nature and they are overlapping, then there will be a problem of redundancy. That means we have to store the
सर composite of nature का क्या मतलब है?
कंपोजिट का मतलब है कि देयर आर एट लीस्ट टू और मोर एट्रीब्यूट दे कंबाइंड मेक द प्राइमरी की. So sometime we have, for example, if we are talking about vehicle, so for
Yes, sir.
vehicle we can have the attributes like engine number, registration
Yes,
number,
sir.
and color of the vehicle, number of wheels, and so
Yes,
on.
sir.
So all these are the attributes. Here engine number is unique, registration number is also unique. So they both makes the candidate key. They both
Yes, sir.
makes the candidate key. But
Yes, sir.
registration engine number is alone. Registration number is also alone. So it is not composite in nature. It is atomic in nature. That means only single value, single attribute is there, which is capable of identifying any row uniquely. But in this case, we have a candidate key. We have two attribute as a candidate key at least. So combined, student and instructor combined will identify the course. Student and course combined will identify the instructor. So that means it is composite in nature. Composite means जब वो दो या दो से ज्यादा attribute से मिलके बने अपनी primary की या candidate की, then we call it as a composite key. Okay.
सिंगल उससे हम आइडेंटिफाई नहीं मतलब अगर हम नहीं कर पाए
हाँ,
किसी
अगर
को
हमें
तो उसको
अकेले स्टूडेंट का नाम पता होगा तो हम कुछ भी आइडेंटिफाई नहीं कर पाएंगे. अगर हमें
Yes,
अकेले
sir.
इंस्ट्रक्टर का नाम पता होगा तब भी हम कुछ भी आइडेंटिफाई नहीं कर पाएंगे. तो कुछ भी आइडेंटिफाई
Yes,
करने
sir.
के लिए हमें दोनों का पता होना जरूरी है.
Yes, sir.
ठीक है. Only then if
ठीक.
both combined are required and they are necessary to identify any row, only then we say that it is composite in nature. So our primary key or our candidate key will be composite. Okay. So
Yes, sir.
what is the problem of this particular scenario? The problem is of redundancy. That means we are storing the same fact again and again. And what is the solution? The solution will be again same. We have to decompose the table. The problem arises because course is determined by the instructor. That means course is dependent upon instructor. Given the course name, I can find the course of that particular, because there is a condition that every instructor will teach only one course. We have discussed it at the very first slide that there are some conditions, there are some restrictions that every instructor, if an instructor is teaching biology, he will teach the biology, he or she will teach the biology, he will not teach the math or science or any other subject. So this means course is dependent upon the instructor. So we have to decompose the table, we have to separate this thing out into a new table, and whatever left behind, that will be our second table. So course instructor, so we will break down this into two tables. One table consists of only two attribute, two columns will be there, and second table is also contain two columns. So in this table, because course is dependent upon instructor, so the primary key of this table will be instructor only, and student and instructor both are required. So in this case, primary key will be a combination of student and instructor only. So now these tables are in 3.5 normal form, which is higher than third normal form but lower than fourth normal form. They are not in the fourth normal form, which is so you are a table will be in 3.5 normal form, or you can say it is in Bcnf normal form. And one thing is to keep in mind that it is the situation that is not very much common. So in order to find out this situation, you have to find out think about the three conditions that must be met uh, in order to normalize the tables into Bcnf form. So I hope it is clear now. So that is all about today's lecture.